Welcome friends, like, share and subscribe for more videos.
Let us first understand the concept of metacenter. For a floating object, the line of action of a buoyant force, acting at a center of buoyancy, and self-weight, acting at centroid is always same. When the body is disturbed, the center of gravity still remains on the centroidal line of the body. The shape of the displaced volume changes, and the center of buoyancy moves from its previous position to new position as shown in figure. The point, M, at which the line of action of buoyant force meets the centroidal axis of the body, when disturbed, is defined as metacenter. Metacentric height of floating object. The distance between the metacenter and the center of gravity is known as metacentric height. The magnitude of the restoring couple is directly proportional to the metacentric height. Larger the metacentric height, better will be the stability of floating object. Stability becomes an important consideration when floating bodies such as a boat or ferry is designed. It is an obvious requirement that a floating body such as a boat does not topple when slightly disturbed. For floating bodies, the stability problem is more complicated, since as the body rotates, the location of the center of buoyancy, which passes through the centroid of the displaced volume, may change. A floating body such as a barge, that rides low in the water can be stable even though the center of gravity lies above the center of buoyancy. This is true since as the body rotates, the buoyant force, Fb, shifts to pass through the centroid of the newly formed displaced volume and combines with the weight, W, to form a couple which will cause the body to return to its original equilibrium position. It is called stable equilibrium. However, for the relatively tall, slender body, a small rotational displacement can cause the buoyant force and the weight to form an overturning couple, which will rotate the body. For the completely submerged body, which has a center of gravity below the center of buoyancy, a rotation from its equilibrium position will create a restoring couple formed by the weight, W, and the buoyant force, Fb, which causes the body to rotate back to its original position. Thus, for this configuration the body is stable. It is to be noted that as long as the center of gravity falls below the center of buoyancy, this will always be true, that is, the body is in a stable equilibrium position. However, if the center of gravity of the completely submerged body is above the center of buoyancy, the resulting couple formed by the weight and the buoyant force will cause the body to overturn and move to a new equilibrium position. Thus, a completely submerged body with its center of gravity above its center of buoyancy is in an unstable equilibrium position.